The topic is on CMAF, and I hope you guys heard about CMAF, right? You did. It's a latest big thing that's happening in industry. It's a new format that promises to unify streaming, but of course you don't switch formats overnight from older formats to new ones. So really, if you think about deploying it, it will have to come into regime when there is already older flavor of HLS, there is already older flavor of DASH, and this is a third thing that comes on the top of it, and how it could possibly be deployed such that it actually saves you money on CDNs and other costs. So it sounds like this is impossible, right? Well, turns out it is, and I'll talk a little bit about it. So the talk really will have a few sections. I'll try to talk about what CMAF is, its history, and so on. Then throw on you a few slides with formulas, and I have to warn you, and since it's not animated, it's going to be full disclosure at each slide. And then we'll try to make sense of it and say what it actually means. And hopefully this will be informative. So CMAF 101. So this is actually the first two slides I honestly borrowed from official CTA WAVE project slide deck. This is their presentation of where streaming is and how CMAF could help. So if you look at this picture, it shows streaming deployments with like 4 different HTTP-based streaming formats, which includes HLS, DASH, and of course smooth and HDS. And the key problem here is that, well, of course you need to encode in multiple versions, but then you also need to send it to CDN, and now at CDN Hcache, all these formats start competing with each other. And so you have higher CDN misses because of this. It's not only cost you to encode content much more, it will cost you to deliver content much more if you have plurality of this format. So the kind of idealized projection of what CMAF can do for you is this picture, where instead of encoding to a plurality of these different formats, you encode only to CMAF, and then you create 2 different manifests, one for HLS, another for DASH, and that's sufficient to cover population of all devices out there. So in theory, it is beautiful, wonderful, and let's also look a little bit what specifically it is and how the whole concept came about. So the credit goes really to Apple and Microsoft, and specifically David Singer from Apple side and Kilroy Hayes from Microsoft, who been working in MPEG, and they really hammered it down as initial sketch of the specification around 2015. And of course it was overwhelmingly supported in MPEG when the concept came about. There were like 20 co-signers of this proposal as it started, and it was developed in very actually record quick turnaround time, considering how standards are usually developed in MPEG. It was done in about 1 year, and that's really unheard of. And it was published in 2017, so it was done in 2016, but publication takes about a few months more. So and moreover, the standardization of it didn't start and stopped in MPEG. So the whole activity got picked up at different level by CTA WAVE project, which is essentially an industrial consortium of companies that are promoting development of CMAF, and they've been working on things like content specification, conformance suite, making sure that there are players out there that can play it. So it was really a massive industry effort to make it happen. And of course, by now we have a number of packagers and devices that can already play it, and there are all sorts of other tools that enable its deployment in practice. So what it means practically, it is actually not that much different than ISO BMFF or ISO-based media file format. It's just a flavor of it. So there are certain different brands and a few differently named boxes and a certain model of what these boxes mean. And it's all actually very similar to what fragmented MP4 is. So there is like concept of chunk, fragment, segment, header, and they all map to DASH or HLS at certain level. So CMAF actually defines not only those boxes and names of and brands of them, but it also provides certain mapping of what they mean in terms of data model and how that data model maps to HLS and DASH. And of course, there are certain differences between them. And just to save time, I'll jump to this table, and I hope the slides will be available later. So this table really nails all the correspondences between different objects. For example, the presentation really in CMAF corresponds to dash period, or the scope of master playlist in HLS. There is no such thing as multi-period CMAF, but there is actually a concept of WAVE program, which is another kind of concept developed outside of CMAF as a standard, but by WAVE ecosystem. So if you want to make a WAVE compliant profile, you could, extend it by existing means, and so on. So there is a mapping between switching sets and adaptation sets, the mapping between tracks and of CMAF and the single data type representation using Dash language or the corresponding variance stream, if you think about HLS. So things do map to each other. And you could actually generate both HLS manifest and or MP3 UA files just using off-the-shelf tools, and many of them are open source. For example, Bento4 supports CMAF nowadays, the same as GPAC, and there are, of course, a number of commercial packagers that can do same thing for you. And on playback side, it's actually supported as well by a number of devices. Of course, Apple came full on board, and effectively all devices that support fragmented MP4, they also can play back CMAF. Chroma did support in version 68, so hopefully, I think it's some time ago it was about 20% of devices on desktops, maybe now it's more. Some latest smart TVs support it, and I heard that Android also planning to support it at some point. So it's coming together, and there are plenty of resources for everyone in industry to kind of take a look at and see if they can deploy it right away or plan for deployment. So that's kind of one-on-one top-level description of where CMAF is and what it means. Now, let's kind of turn the page and let's try to think about what deployment of multiple streaming formats actually mean from CDN performance perspective. And of course, for that, we will need to use a little bit of math. I warned you about this a bit. It's very simple. And I skip some details. So, but the first thing that as first questions that we need to answer is this: what content gets cached on CDN? And to do that, what we really should do is we should look at, let's take a set of items. Let's call them S with some index from 1 to, some large number, maybe infinity, and define the popularity probability distribution over those items. And what's beautiful in nature, and at least in variety of domains in nature that we studied, is that many objects such as popularity of words in language or popularity of different content that is distributed on YouTube and so on, they usually follow certain monotonically decreasing probability distribution, and there are many sort of rule of thumbs laws and rules describing those probability distributions. We know things like zip distribution or pair to rule. And what I'm using here as a model, it's a so-called zeta distribution, which really is one of the variety of existing discrete distributions that describes this kind of phenomena. And on top plot on the left, I show a few model distributions produced by using the formula. On the bottom, I just pulled experimentally measured popularity distributions of content in YouTube, and you could clearly see that that model looks close enough to what is known as one of the biggest sources of video content out there. So hopefully it's a good enough model to use. And on this topic, I'll also say that there is a whole domain of science which is known as content-centric networks, where they use very similar distributions to model and describe what they do. So it seems that stepping on this model, we're stepping on something that's been established. Now, of course, we need to understand what's going to get cached, we need to assume what the size of the cache is. So I've used C as number of items, and then if I know how many items can stay in cache, I could assume that, okay, if cache designed right, it will just store C most probable items, right? And if it's C most probable items, then probability of miss is going to be 1 minus the sum of probabilities of those most probable items there. And that, of course, becomes this very simple formula, which uses generalized harmonic number, or it actually has very nice asymptotic expansion. If C is large, then it becomes even simpler. So the model is actually very simple, beautiful, easy to work with, and there are plenty of examples of using same exact model in similar contexts. So this is good. Now we know what could get cached on CDN cache. And now let's try to think what's going to happen if we have two versions of content that go now to cache. And what happens is that, well, to model this, let's assume that we have one set of items as subindex 1 and another subset which is as subindex 2. And we also let's define what is the relative usage distributions of those two. For example, if one item is HLS, we could say that that's used with 75%. If another is DASH, that could be used with 25%, of course, depending where you're deploying it, right? And who are the clients. But what's important is that you could specify some parameters that will say what is the relative usage of those two formats, right? And if we know the relative usage of these formats and we know the content popularity distributions, then we can compute what would be absolute or full probability of each content item, considering popularity or usage probability of the format plus its popularity by itself. And if we have, and those probabilities, of course, are product of those two quantities. And then what happens is, and this is probably the most tricky thing in this whole analysis, is to really try to look what's going to stay on top of the stack in a cache that now will deal with these two sets. And let's assume that first set is more probable, it's more heavily used, and then, of course, the first item from that first set is going to go to the top because it used to have the highest probability, and now it's more used. And it turns out that several of those higher used type will stick to the top till the point where the probability of top item from second set will match the one that was from first one. So that will be the first instance of content from second set, and then there will be more items from first set. Then there's going to be another item from first set, and another. So in other ways, they will get interleaved. And if they're going to get interleaved, we can actually even compute the step size at which that interleave is going to happen. So this is really the only things that required a little bit of imagination to try to think what's going to happen. And now, as we know that the two formats get interleaved, they stay on the top of the cache in this pattern. The rest is simple math. We could asymptotically show that CDN cache miss probability in case of using this mix of two formats becomes pretty much same formulas as we've seen before, times this little term in the front, which is probability of first set to the power of 1 over alpha plus probability of second set times 1 over alpha, and to the power of alpha together. So it's basically L norm of some sort. And of course, we still need to know the cache size to derive this probability, right? But now, if we will ask question, what is not this probability by itself, but what is its change relative to the probability of system that has just single format, and we just divide these two quantities one by another? Well, remarkably enough, that cache size goes away in a asymptotic sense. So basically, you see, let me use fingers here. So this whole formula basically falls in as a second term in first formula. So if you divide them two by themselves, they will cancel out. And what's gonna stay in front, front term is gonna stay as stable. So now what we can say pretty surely from mathematical standpoint is that if the cache size is large, and in one case you used a mix of two contents, right? And in the other case you just used a single format or a single version of the format, then the change of cache miss probability that will be introduced by the fact that now you use two formats will be that particular quantity. And of course, it is I produce plots of how it looks like relative to this usage probability P1. And of course, what we can see is that if usage probability P1 is 1/2, which means that both formats equally probable, that will introduce the worst impact on the cache miss probability. And if one of the formats is less probable, then it doesn't change much. Now, with three formats, the whole thing is actually very similar. It just takes a few more pages of Mathematica to derive it, but it basically similar term. We just have now three component usage probability terms that forms this ratio factor. And of course it also looks like a convex shape with maximum at the equal balance point. And extending it to n formats, we arrive also at same exact factor with k elements, and this is basically what it is. It's just LP norm with parameter 1/alpha. Now, what it all means? It means that if you have multiple formats and they are equally probable, that's where you're gonna have the worst impact on your CDN performance. That's where those formats will compete with each other and will replace each other with most severe consequences for you. Now, if one of the formats is becoming highly usable, its probability approaches 1, the whole term approaches 1 as well. So it means that in that case, your system performance is not affected. And this gives us very simple recipe to success. If you have multiple formats and you want to minimize the cache miss impact on cache miss probabilities, just make pick one format and send as many direct to as many clients as you can to use this single format. The more asymmetry in that distribution, the less impact is going to be on the performance. So that's kind of what we can say about this problem by looking at it mathematically. Now, going back to CMAF. Of course, we cannot deploy it as a thing by switching overnight and making all players magically using it. Some players out there will still can only support older HLS. Some players will only support MPEG-A, DASH, and some new players will support CMAF. Now, what we really are comparing here is a system with 2 formats versus 3 formats. And we already know the cache miss probabilities by formulas of what they will be. And of course, we can compare now 2 format system versus 3 format system and see what at which point adding 3rd format might actually help. So how we do it is very simple. So again, now I use row instead of pies to describe probabilities of 3 format system. And what I will say is that let's kappa represent the percentage of HLS and DASH devices that will be supporting CMAF. So let's assume that kappa will say how many of existing devices out there that currently support HLS or DASH will be able to switch to CMAF. And if we know this percentage, then we can, of course, derive the probabilities in second system, and then we could look at the cache miss probabilities in comparison, and or equivalently by considering a large cache scenario and asymptotics that associated with this. We could, it all boils down to this parameter delta, that in cases if it's less than 0, it means that system with 3 formats is better than system with 2 formats. And here it is. Basically, that's a plot of this parameter, of this finite term delta. And of course, there is a region, so this flat thing is a plane of z of delta being equal to 0, right? And of course, there is a region, and everything goes below that describes a combination of parameters, such as percentage of devices that support CMAF, plus what is the current balance between DASH and HLS in the system, that's P1. And based on this, we could say at which moment adding CMAF is actually going to help. And so this is good news that it actually can help, as we can see from this formula. The bad news is that if we plug in some ballpark numbers, such as popularity distribution shape factors that matches what YouTube tells us, plus we assume that 75% of devices is HLS and the rest is DASH, then it boils down that you need about 84% of devices supporting CMAF as a kind of break-even point at which, considering cost of CDN, adding this third format is it's gonna get an equilibrium, and if there is more devices, then you start begin to save money by using this common format. And of course, in the future, as we expect more and more devices supporting CMAF, that we're gonna trend further and further away down to the extreme right end of it, so the savings will be most significant. So a simple model gives us a good estimate of how much devices you really need to start using it. And for some customers, streaming, for example, to some set-top boxes that already can support CMAF, or streaming to Apple devices in large quantities, maybe they're already close to 0.84 or 84%, such that for them it actually makes sense. Related problems. Of course, streaming in general is a concept that is been abused in recent years. We have multiple resolutions and multiple bitrate encodings of same content, so that adds redundancy of content in its own representation. In a way, it's encoded by itself. Then we have multiple formats in which it can be packaged. Then we have multiple encryption and DRM schemas, and different system level specs, such as HLS, DASH, MMT. By the way, it's another MPEG standard for system delivery. And last meetup, I remember talk by Phil Clough talking about SASH. So, you know, who knows? Maybe there is another one coming, right? And of course, there are multiple codecs. And honestly, I don't think these problems are gonna go away. With codecs wars ongoing, different camps claiming that AV1 is fantastic, and other folks saying that VVC is gonna, rule the world, and as well as, obviously, competition at the level of platforms. I don't think we're gonna merrily move in the situation when all those problems gonna go away, and we're gonna get to a single standard or single format quickly and surely. But the good news is that as messy as this deployment will look today and in the future, we at least could model some of these effects. And the moment we can model them, we can quantify, understand what it means in terms of costs, and hopefully tune systems such that they perform better. And of course, conclusions. CMAF, considering everything that I say, in my view, is certainly one of the brightest things that's been done over the last decade in streaming space. It really tries to enforce convergence, and we are getting closer to the tipping point where deploying it is going to be no-brainer from multiple perspectives, including CDN costs. What was done in this presentation is we showed that how this could be modeled and how we could understand at which point that deployment will make sense, and that actually the same concept applies to a variety of related problems. You could model the impact of having multiple streams in streaming systems, and if you generate profiles, do you really need to have 100% increments between rates, or maybe making it bigger will actually reduce your buffering probability and such? So those things can be tackled by certain mathematics. Hopefully, things I sketched is a step in the right direction, and perhaps most fundamentally, a more glorious or noble thing to consider is how to design a system in principle, such that you don't generate plurality of description of same exact content in principle. So if you know how to do it, have any idea, let me know. I run research team at Brightcove, and we are always trying to look beyond what is currently feasible or deployable. Thank you very much. It is really a question of what population of users you are serving and what is the split between their devices. As I mentioned, if this is majority Apple devices plus some smart TVs, very little Androids, you actually might be already past that point. Okay, you asked two questions. Let me try to answer the first one. Well, it's a common anecdote in standards community. We have n standards, and somehow they are not good, so let's create n+1 and that will make world better. Well, guess what happened next 3 years? The same people get together, now we have n+1 standard. And this continues, but each standard is different, and this particular one was actually designed with the idea of unifying things together. So I think this standard has noble roots, and it's actually getting there. Second is doing fragmented MP4 HLS versus DASH with same fragmented format. Well, if you look at CMAF and specifically whole suite of specifications and tools that were produced in CTA WAVE project. If you look at conformance suite, if you look at content specification, it goes to the level of detail that is way beyond of what is currently allowed if you just follow Apple spec. So if you take the route of following CMAF and the latest conformance tools and specifications that this group of companies has produced, by the way, Apple is one of the members of these companies, of CTA WAVE, you are on a much sure route to produce content that will be playable by devices out there, and you're not going to end up with content that looks like it's conformant, it plays on Apple devices, but oops, on this particular player with this particular device, it doesn't work anymore. So that's my view on this, and I would certainly advise to, since there is momentum on CMAF and all companies contributed to this, let's not reinvent the wheel and create yet another flavor. And okay, I'll tell you how to map it to what I'm describing. Of course, if you go into mechanics of each implementation of each CDN, they will have slightly different algorithms. They all use RLUs of some sorts, and some use pluralities of RLUs associated with different sizes of content items that goes in different queues, right? Now, what we look here as a problem is the situation when you have two different formats of same exact content. So regardless of which format you are using, they're gonna go to same exact queue and will compete against each other. So that stack model that I was showing, it will be applicable, and the C parameter of the size is eliminated by cancellation and asymptotic. So it actually, if you think that the CDN cache is large and the percentage of storage that's allocated to your content is also relatively large, it doesn't really matter in which queue it goes. In the scope of this problem, that model still applies.
So the benefit is the same?
The benefit, well, now, where you will need to account for those differences in algorithms on CD instance when you start looking at not only different formats, but different, for example, compression efficiency of different codecs, because that might trigger the content encoded by HEVC, for example, to go in a different queue and in a different RLU as opposed to one that is encoded with H.264. That might change a bit of fundamentals, but then I would advise, talk to your CDN, figure out what they're doing, and apply a model that is adequate for that case. Well, I'll tell you this. What Brightcove does in terms of deployment system is called dynamic delivery, and it's a much more sophisticated system. It tracks statistics dynamically. It will really be another talk that I could give another time to go to details of this. But basically, if you want to serve content optimally to a particular customer, you really need to take into account full specifics of that deployment and optimize to that.